In the world of Ethereum, staking isn't about vampires. Gas doesn't come with a monthly bill, and smart contracts are the new rule of law. If it sounds confusing, don't worry, after this video, you'll be able to give Vitalik a dApp. Let's get it. Welcome to BitBoy Crypto. My name is Ben. In this video, we're going to cover some of the basic terms in the Ethereum ecosystem and catch up on some of the new terms that have been popping up as the network scales. Let's start with the basics. Smart contracts, an essential part of Ethereum's infrastructure. Smart contract is a self-executing contract with the terms of the agreement directly written into the code. An easier way of thinking about this is as a system that is programmed to deliver certain outcomes when it receives a certain input, essentially automating the process of deal making. Think about the mechanics of vending machines, which are programmed to dispense certain items when they receive the required amount of money. That would be an example of a smart contract in the physical world. Now, just think of those same mechanics applied to certain online transactions. The possibilities, well, frankly, they're endless. A unique programming language called Solidity was developed for writing the smart contracts on Ethereum. Now, Solidity is similar to JavaScript, but it was created by the early Ethereum team specifically for smart contracts. Moving on, there's the Ethereum virtual machine, or EVM, which forms the soul of Ethereum. It's not a physical device, but a runtime environment that executes all smart contracts on Ethereum. The EVM model has come to dominate the smart contract space and is even used by competitors like Binance Smart Chain. It's beneficial for competing chains to be EVM compatible because then it's much easier for them to recruit developers who already know how to code on Ethereum. EVM-compatible chains can also be programmed in a variety of different languages, so developers can venture outside of Solidity if they need to. Then there's gas, the fuel that powers Ethereum. Gas isn't a token or a coin, but a unit of measure for computational work. Every transaction on Ethereum requires gas, and the more complex the transaction, the more gas you'll need. The minimum gas required for each transaction is known as the base fee. Transactions also have a gas limit, which is the maximum amount of gas that can be used in one transaction or block. The price of transactions at any given time is measured in Gwei. Gwei is a fundamental unit of Ether, much like Satoshi's are to Bitcoin. It's like the change in your pocket compared to a whole dollar bill or the cents to a euro. The term Gwei is actually an abbreviation for Gigawei. It's named after Wei Dai, a computer scientist in early cyberpunk, who was one of the pioneers of the crypto industry and actually someone we detailed in the book Catching Up to Crypto. Another term you may have heard is dApp. This is an abbreviation for decentralized application. It has nothing to do with that weird handshake thing that some people do with their friends. These are applications that run on the Ethereum blockchain, offering users a variety of services from games to decentralized exchanges. Unlike traditional applications, dApps are open source and operate autonomously with no central authority, at least in theory anyway. Many of these applications start out centralized with plans and hopes of decentralizing in the future. When this time comes, these apps can be governed by a large group of stakeholders instead of a central authority. These groups of stakeholders are known as decentralized autonomous organizations, or DAOs. These are essentially digital versions of cooperative businesses, where numerous stakeholders of builders, users, founders, and investors all share partial ownership and responsibility in the platform. DAOs create an organizational structure where every participant has a say. But there are some problems that need to be fixed with this model before this utopian vision can become a reality. Right now, most DAOs are run by token voting governance, which means that whoever has the most tokens has the most say. This has led to a situation where many of the protocols are controlled by VCs, just like they would with traditional tech. But there are projects that are working on solutions to this problem and developing new ways of doing business. A great example of this is Gitcoin, the fundraising project that supports open source development on Ethereum. Gitcoin uses a mechanism called quadratic voting to ensure that people with just a few Gwei can still have their voices heard, along with the whales. Many teams are hoping this model can be applied to DAO governance as well. Other blockchains now have things like dApps and DAOs, but Ethereum was where these breakthroughs happened first. A lot of new terms have been written into the Ethereum dictionary over the past few years because the network is always growing and scaling. Some of the new terms relate to the scaling of the Ethereum blockchain itself, while others relate to the assortment of Layer 2 networks that have started to pop up over the past few years. The most important change has been the shift from proof of work to proof of stake. For the average user, things work pretty much the same. But under the hood, the network is no longer secured by miners. It's now secured by users who stake their coins and run hardware at home. These users are known as validators. They take a very similar role to miners, but they aren't mining anymore. So they're called validators instead. Staking gets extremely complex, and we could do a whole entire video just related to the new terms surrounding staking. But for now, let's move on to Layer 2 networks. Plenty of blockchains give support to Ethereum, but not all of them are considered true Layer 2s by Ethereum developers. The most secure Layer 2 networks are Rollups. These are connected blockchains that execute transactions off the main Ethereum chain and then post the transaction data on the Ethereum blockchain in large batches to reduce the constant transaction flow that clogged up the network. I think of this as kind of like the Lightning Network on Bitcoin. This helps to relieve congestion on the Ethereum network and reduce fees, while still maintaining a high level of security. There's a catch though. Many of these rollups are very new and are still in their beta phase. They're basically running with training wheels, which means that the teams still have a high level of control and are able to change the contracts with a multisig login. Multisig means multi-signature, and these are wallets that require signatures from multiple people in order to log in, as the name implies. These types of wallets are usually used for businesses and organizations where funds are shared, and also in cases where security measures are taken to remove a single point of weakness. However, even though this is safer than having one person with the keys, it's still less secure and decentralized than distributed ownership of a DAO. If you want to experiment with one of these rollups, you're probably going to need to use a bridge to move your funds from one blockchain to the new blockchain. Bridge is a bit of a misleading term for this type of service though, because you don't actually take your money over to the new blockchain with you. What you're taking is basically an IOU, a new version of the asset on a new blockchain. The bridge is just an intermediary who is holding your money for you and keeping track of how much you spend while you're on the other side. If you want to transfer back over to the old chain, you go back to the bridge with your IOU and you redeem your original assets on the other side. There's no problem if the bridge is secure and trustworthy, but we've seen that bridge hacks have happened before. And when they do happen, they tend to be big because if you think about it, bridges are big piles of money just waiting to be taken. Rollups have official bridges and third-party bridges. The official bridges are much more secure, but they also can take much longer because the network needs to determine whether or not your transaction is actually legitimate. Now that should get you up to speed on all the major terms in Ethereum, but the lexicon's always growing. So try to keep up with the developments if you can. That's all I got. Be blessed. BitBoy out.